Yes.
Well, good morning and welcome everybody. I will just give you a very brief, short introduction, and then I will hand over to Ute. As you probably all know, or hopefully have heard from ICOS, we are representing a research station network across Europe with well over 100 research stations, and we are measuring and collecting greenhouse gas concentrations, fluxes, and so on. If you want to know more about the ICOS, because this is not about ICOS, so please go to our website. There is plenty of information there, what we are doing and why. But in essence, it is we collect the data. It is all free. It is all as fair as possible, public available. And what we're going to show here today as well is that we have a public available virtual research infrastructure or environment where you can log in, use the data, and do research or just explore what we have. Yeah, since this is virtual, so that's me talking, Claudio. Then follow-up speakers will be Ute Carstens, Carolina Vantasatu, and Ida Storm. And so for this workshop or webinar, what is it what we want to do? We would like to showcase you this Stilt web application we have. And on top of that, Ida will show you how she created a new data product based on this Stilt web application. And we will keep everything rather short in talks and slides because the second part is an exercise or hands-on Jupyter notebooks where you all can log in and you will do your own little program, let's put it this way, with guidance from us. So this is the schedule we have imagined. Again, we will have about 25 minutes now, as in slides and talks, a little break, and then we will have 2 hands-on sessions where we create a interactive map together, and then a time series plot comparing the model output with observed data. And with that, I think I'm gonna stop sharing now and give the floor to Ute.
Thank you, Claudio, for the introduction. I will start sharing, hopefully. Here it is. So I hope you can see my screen now, because I cannot control, yeah, I can control what you see. So I'm going to give you a very short presentation of one of the services that we have implemented at the ICOS Carbon Portal to serve our community of researchers in ICOS and beyond. So this is the Stilt footprint tool that we have implemented. Stilt is an atmospheric transport model. It is used to compute footprints and greenhouse gas concentrations at the ICOS stations. You could also run it for other stations, of course, but this is the kind of service that we are providing. Just as a short explanation, so we are often using this word footprint. What is a footprint of an atmospheric station? So it is the source area that has influenced the greenhouse gas concentration at the station. So imagine that the air that travels towards your station passes over an industrialized area, for example. Then the emission sources will increase the CO2 concentration in this example of the air package. And then as it is transported to the station, when it reaches the station, the concentration that is measured at the station will be enhanced. So it's just the simple area which has influenced the concentration. And then, of course, the question is, why do we need to model the footprints and the concentrations? With this service, we want to provide a tool to analyze the potential impacts of natural and anthropogenic emissions, for example, on atmospheric greenhouse gas concentration measurements. This is, of course, only the potential impact because it is in the modeling world. But in the modeling world, we have the advantage that we can easily separate natural from anthropogenic emissions. So we can look in more detail into where the emissions came from and what were the sources, which is for sure not easily possible with the measurements that we have. So we hope to give a little bit of background information to our users. So now some more technical information. So it is a web-based service, this footprint tool that is implemented at the ICOS Carbon Portal. It consists of two different parts. So one part, which is listed in the lower bullet point here, is an open access Stilt Viewer, where you can view the results that we already have. And this is open to everyone. And then we also have the on-demand Stilt model calculations. So the user can really initiate a calculation with this atmospheric transport model. So for this purpose, we have implemented the model in a virtual machine so that it is scalable and it is transferable. So we can use it not only on our own ICOS server, but we can also have this running somewhere in the cloud. And also, if we have higher demands, we can just create more virtual machines on different servers. So this was started in a collaboration with the EGI Federated Cloud, so we can use a combination of resources. To give you an idea, it is computationally intensive, so you need around 300 CPU seconds for computing a single footprint. A single footprint in the end represents one single measurement state. So if you have hourly time series, you can imagine how many measurement dates you have. That's why we have also restricted it to 3 hourly computations. And as this is a bit demanding, it also requires authentication. You just have to be registered at ICOS. And below you see the link. And if I click on the link, it should take me to the thing. And now I will start sharing my other screen. Maybe not. Maybe I give you one more information, which is the just a sketch of how this is set up. As I said, we have this atmospheric transport model, which is running in a virtual machine somewhere in the cloud on our server, wherever. Our users log in via the ICOS Carbon Portal. And it's not only that it is intensive with respect to CPU time, it is also needing a lot of input data because we need, for example, the atmospheric wind fields, and we need the emissions. So this amounts to several terabytes of data, which are then mounted to the virtual machine. And it also produces some terabyte of output data, depending, of course, on the amount of stations we want to do the calculations for. But now I will share my other screen. I hope it will work. And share this one and share this one. Okay, I hope you can see now something that says Stilt Calculation Service Job Starter. It seems that you should be able to see this. One very important point is that in order to use this, you have to be logged in with your Carbon Portal account. I already logged in before, so I can start computations. You have different ways of selecting a station for which you want to do the computation. You can, for example, select from this list. Here we list all the stations for which we already have computations available, or you can just go to the map and select a point on the map. For example, we could just think of doing a calculation for this point. That's where I'm actually located at this moment. But I think it will be more instructive if we do a calculation for another station for which you already have some data, because then you can explore the data later on yourself. So for those where we have already data, we have stored the site ID, and we have also stored the latitude and longitude and the measurement altitude above ground of the station. So I will load this information to the tool, and then I can give start and end date of the calculation. I will just do this for the beginning of 2019 and just for a few days. Let's say for the first 4 days, or let's say 5 days. If you remember correctly, it will take a few minutes to do so. So I submit the job, and then I have here this list of submitted jobs. These are all the finished computations, and this is my actual computation, which has been sent to the queue. We can look at some details here. So this is now showing the dashboard where you see the queue. Here's the total amount of CPUs that we have set aside for this service. At the moment, we are working with 20 CPUs, but we could use more. And if we have high demand, as I mentioned, we can also spawn more virtual machines in the cloud. At this moment, we have 12 free CPUs, so 8 CPUs are busy. And this is because I started the job for the 1st of January to the 5th of January, but I had already pre-computed some of the days. So the first days of January I already computed yesterday to test this exercise. So 32 of the time slots are already available. So this will now take a while. As I said, it's about 3 to 5 minutes, depending on the load on the server. But let's imagine we have already done a job like this one, where I computed for the 3rd of January computation I did yesterday. We can then go and view the results. So now we come to the Stilt Viewer, which is similar to the viewer, which is openly available. I will try to take you through this maybe a bit busy interface. So what you see on the upper left-hand side is the footprint for one of the time slots. You see here again the map with the stations, but you cannot select the station because it has already been pre-selected, because it is just for these few time slots that you have just computed. So start and end date. And now I try to scroll down. I hope this will work, and you will soon see the time series plot as well. So this is now the time slot for which you see here the footprint. So here's the station, and everything that is reddish, yellowish is the footprint. So from this area, we get information. We get CO2 being transported towards the station. So you can also walk through this. So you can step through time and start, for example, at midnight on the 3rd, and then move on in 3-hourly steps, as I mentioned. And you can also animate this so that it continuously runs. And you see here this footprint moving. Let's see if we can see if our job is still busy. I will just reload the page to see whether it is working. It is still busy. So it has now 36, 37. So it is finishing up, but I think we don't have to wait. You saw, I guess, the idea of it. You can always, now it's done. I just wanted to tell you that you can always cancel the job, of course, if you think, oh, something wrong. it is a bit difficult to find your results then, because it's not ordered by anything. But never mind, you saw the point, I think. I will now take you to, if I ever can get there, to the Stilt Results Viewer. So this one is the open access Stilt Viewer. Here we have everything that has been computed available for our users to display the results. And also the results that we have just produced are already available here in this Stilt Results Viewer. So if we again select a station, now we can select a station because, as I said, it's everything we have. You can see it's a long list. I hope you can see that I'm scrolling through this list. I cannot really verify this on my screen. Maybe I should switch off my camera. So I now select Torfhaus, the station that we were looking at before. I just scroll through this to find.
So, just so that you know, we cannot see your drop-down thing, but we can see the result of your selection.
Okay, so what are you actually seeing at this moment? Okay.
That you have selected the Torfhaus station.
Okay. Sorry that I didn't test this yesterday with the drop-down. Thank you for the feedback. So now I have selected Torfhaus for 2018, which is the year before I started the computation. So again, you see here in the upper left the footprint, and I will now scroll down a bit so that you can see the time series for the full year. And we always display the footprint for the center time. I will try to go through the animation, but I'm not sure it works. It will probably be very slow here.
Works fine on my screen.
Okay, perfect. But I will stop again and point you to some other ideas. I already said that in the model world, we can easily distinguish between CO2 coming from biospheric sources and coming from anthropogenic sources. And this is something that you can see here as well. So this is now the total concentration that the model kind of predicts for the station. We can also split this up into the CO2, the CO2 from the biosphere, and this is now displayed in the green line. And here, for example, you can see that in summer you have reduced concentrations because of the uptake of CO2 by the vegetation. And the other component would be, for example, the anthropogenic CO2 coming from anthropogenic emissions, which is now displayed in the red line. And then if we, for example, to just show you how this looks like, go to this peak where we have high concentrations coming from anthropogenic emissions, you see that the air has spent quite some time in the Ruhr region of Germany. So that's why we have these high concentrations. And if we then step further, it will move. The footprint will cover different areas. So that's it for my example, and I will try to share again my presentation. Okay, so now my presentation should be back. I will just quickly, I had made some screenshots for you because you never know if it works. So now I'm back at my last slide. As I already mentioned, all the footprint and concentration results from the on-demand calculations are instantly available at ICOS Carbon Portal, so they can be then used for further analysis. And one way of analyzing them is to use Jupyter notebooks. And the data are directly available in these Jupyter notebooks. So it's very easy to do comparisons, for example, with ICOS observations. That is something that Carolina will present you in one of the hands-on sessions. But you can also combine this with additional data sets. And this is then what Ida will show you in the next part of the presentation. But are there any questions before we move on to Ida's presentation?
Hi, this is Alba. I actually have two questions, if that's okay. Yeah, so I was wondering what is the technology behind this this tool, and also I was also wondering if this the results are somehow OGC compliant, like or do you have web services like I don't know, web feature services or something like that, or WMS?
Yeah, maybe I'm not the person to really answer this question, because I'm the one who is really running the model and not looking into all the technology in the background. So the model itself is just a computer model, so it runs in an R environment. But for the exact technology, just send me an email and I will forward it to the person in our operations team.
Okay, thank you. Yeah, I will.
Are there any more questions? If not, then I will stop sharing my screen so that we can move on.
All right. Can everyone hear me? Okay.
Yes, thank you.
Yep.
Great. I had some mic problem yesterday, so I'm so happy I can be heard. Now I'm just trying to figure out, okay, I can move this. So Claudio, I don't know if you wanted to introduce me, but I went ahead and shared my screen at least. I don't know if you want to say something.
Well, just do it yourself. That's fine.
Okay, here I am at the station characterization, where I give an example how you can create a new data product based on these stilt footprints. We've learned about from Ute. Thank you, Ute. It's always interesting and nice to hear about the stilt stuff. So station characterization then. So Ute mentioned that we can combine these footprints with additional data. And here is an example of that. And we now just look at screenshots, but this is a tool that is in a Jupyter notebook that I will share a link to. You can go in and play with it at some point. But for right now, I have just showed the same footprint that you saw in Ute's presentation for Gatov for a specific point in time. And then on the right side here, I've just zoomed in so you can see how this stilt footprint grid looks like, because it is a grid with 480 by 400 cells. So you see here they're 1/12 latitude by 1/8 longitude degree, these cells. And if we think not about the footprint now, you see that obviously there is specific areas that have specific land cover types. So here you see broadleaf forest in this zoomed area. And what we want to answer in the station characterization tool is then what is seen by the station. So what is seen in this footprint area. So here I have overlaid, instead of just an empty grid, you can see the colors corresponding to how sensitive the footprint is to that specific area. So what happens is then that you have the land cover under there. You have an area of land cover of broadleaf forest in each cell, and you weigh it by how sensitive that cell is. So that's the color then corresponding to how much. So what you can do is then, I don't want to look at just a single point in time, but rather I'm interested in Gatov. Okay, so what can we expect from measurements at Gatov? What kind of land cover has it passed on the way? So I have on the left-hand side here aggregated you average all the footprints for Gatov for 2018. That's every 3 hours. So if you're quick with math, it's 2,920 footprints. So then I have averaged that, and you can get a % sensitivity to each of these bins, so you get an idea. And then exactly what you did for the broadleaf forest, how you weigh the land cover by the footprint, you can do that for all different land cover types. And to the right here, we have something that is an output from the station characterization tool, where you see in each of these direction 45-degree bins what land cover is in that area. And as you can see, the bars are of different height, and you might wonder why. But then you think that this is weight by the footprint you see to the left. So in certain directions, there has been maybe more of a dominant wind direction here, for instance, from the west, that the air is usually more often coming from there, to just simplify them. So that's the reason for the different stack heights. And then you can see then the breakdown within each of these 45-degree bins. I don't know if you can see my cursor, but the north is then this area. So all the way up to here. So what is in that area? And there are other output visualizations in the notebook, in the tool. So you can combine it. Now I showed for broadleaf forests and the other land cover types, but I've also done a weighing by population, for instance. So you can see, well, where within the footprint are people living, and kind of see a map of that. So I hope I've now awoken your interest, and that you will follow this link and try it yourself. Maybe not right now, because we have more interesting stuff coming up now, but I know you guys have some off time where you can work on things. But like Ute said, the footprints that are used in the tool is directly accessed in a notebook then. And if you go ahead and follow Ute's instructions to generate or produce footprints, then you can directly use those in this tool. You could even create a hypothetical station. I actually did that myself. I have an EDA station located somewhere in Sweden, I think, just when I did the tests. So I could then do a station characterization for the EDA station and understand, well, what land cover breakdown does EDA see, and what populations is in the footprint area, etc. And you can specify other parameters, such as you now saw the average footprint for 2018, but you could instead focus on, you could do it for one footprint, like the Gatov specific footprint that you saw in the first of my slides, but you could choose any time period, and you can choose specific hours and stuff. And you can also do the binning. If you remember the average footprint, then that was 15-degree bins now at 100-kilometer intervals, but you could get different aggregations of the footprint then. But yes. And then this third point here, option to generate PDF with results, that is in progress. So if you guys go on this link, maybe in a couple of weeks, that will be an example, an option. So what you do then is that you run it, and then, oh, I want the PDF with my results, and you get more information then, and you can share that PDF with anyone. But that's all that I have. Let's see, next will be log into VRE, and that's with Carolina. But I will stop sharing now, unless anyone has a question while I still have my slides up, maybe. I give you 4 more seconds. No. Okay, great. So Carolina.
Thank you very much, Ida. I'll just try to share my presentation.
Oh, your audio is not very good, Carolina.
Oh, apologies. 1 second. Is it better now?
No,
No.
I'm afraid not.
Okay, I will log out and log in again.
Okay. Well, in the meantime, maybe I can skip this part. So you should see my screen. So Carolina will be back in a minute or so, hopefully. She will talk about how you can log into our Jupyter service. And once she has done that, or maybe you can even already kind of start. We have a document, and I will copy this link here in a second to the chat box, if that is possible. I haven't tried that actually. And then I would ask you to fill out, I'm gonna open this now. If you could fill in the location where you are currently. So I have taken the registration list which you filled out. So you should find your name here. If not, you can just add a line with your name. But most importantly in this list would be, oops, sorry about this. There we go. There is a column for latitude and longitude. So if I could ask you all to fill in the latitude and longitude, or I mean, if you would like to share this, you can, make up a position. That is fine with me, but just put in some sensible values of latitude and longitude. And this will be then used in an exercise in a couple of minutes. So I will try now. Oh, sorry, you don't see my screen. Oh, that nobody told me. Okay, so again, if you go on that link, which will I post, you should end up in this file. And you will find your name, hopefully, and then you can fill out latitude and longitude for yourself. And I can see that people are already starting to put in numbers, so that is excellent.
Yes, both me and Ute shared the link in the chat, Claudio.
Excellent, thank you. That was very helpful. So I'm going to close this now, and we'll go back to see if Carolina is back online.
Yes, I am. Is the sound better now?
Yes, perfect. So I'm gonna.
Oh, great.
Shall I just keep the shared screen for you?
Yes, sure. We can do it like this. So, hello everyone. Together we are going to get everything set so that you are ready to start working on the exercises that Claudia mentioned and are included in the upcoming hands-on sessions. If you experience any problems or have questions regarding this part, just interrupt me and ask your question. Alternatively, you can also put your question in the chat where I will post the link that you see in this screen. So go to your Chrome or Mozilla Firefox browser and enter the URL that I posted in the chat or that you see in the slide. And there you can add your email address as a username in that field and the password MSA, as shown in the slide, in the corresponding password field. So if everyone tries to do that.
Oh, and could I, Carolina mentioned this internally before, so people from the ICOS Carbon portal, could we ask you to use your Jupyter login and not explore data? We have a restriction of 40 logins. So just to make sure that everybody who is participating here now has access. Sorry, Carolina.
No worries. Thank you, Claudia. So just let us know if everyone experiences any problems. Logging in, because this is an important part. If you cannot, you will not be able to work with the exercises along while Claudia and me are presenting them.
So we're going to switch now to workshop. So just unmute yourself and tell us if.
This is meant to be an interactive part, so just please communicate with us.
I could log in just fine to the Jupyter
me
notebook.
too.
Perfect.
And,
so if we do, yeah.
Yeah, and I'm also trying to figure out my location and fill in the info on the shared table in the meantime. So.
Okay.
Good.
Perfect.
Excellent.
So maybe we give you a few more seconds while we show this slide. Well, the only thing you need to remember basically is to use your email address as a username, and then the password is MSA. Otherwise, you have all the other information in the chat.
Yeah. For logging in, it is as simple as that. So
yeah,
works.
perfect.
Works fine.
So maybe Claudia, we switch to the next slide. So once you have successfully logged in, you will be you can see a set of folders, and the exercise that we're going to use today, they are inside the folder called Project Jupyter Notebooks. So if you click on the name of the folder, you will be redirected to well, inside that folder. And then you will find a list of project folders that we have here in ICOS. And today's project folder will be the ENVRI Winter School. So click on that, and then you will be able to see the notebooks and the exercise material that we have prepared for you. So while you're doing, yeah?
Yeah, I just wanted to say that I cannot edit the shared document yet. I don't know, maybe I have to refresh the page, but it's not working.
Maybe give it a rest and try again a few moments later and try to refresh the page. Maybe there are too many people accessing it simultaneously now.
Yeah, true.
So just try a little bit later again, and it will work. So if everyone has been able to get into the exercise folder, the ENVRI Winter School, maybe
Yes.
I can take up, good. Maybe I can take up a few moments and explain shortly again what a Jupyter notebook is. Just as a quick reminder, so a Jupyter notebook is an open source web application that allows users to create and share interactive documents containing live code, equations, visualizations, and narrative text. As the slide shows, this is an example of how a notebook looks like in real life. As you can see, it consists of markdown cells in which you can then add text, images, and links for documenting the code and the methods that you apply in the code. A notebook also includes code cells, where you can write your code. You can execute such a code cell by selecting it and then simultaneously holding down the keys Shift and Enter, or alternatively simply by clicking on the Run button that is located on the toolbar at the top part of the notebook and is highlighted in yellow in the slide that you see. Then the output will be presented just under the code cell that you have executed. The top part of the notebook includes a menu bar with all the operations that you can perform over a notebook. And just below the menu bar, you will find a toolbar that includes buttons for performing the most common operations, like executing a code cell, adding a new code cell, stopping the execution, or changing the type of a cell from markdown to code, for instance. And Claudia has already given the instructions on how you can enter your location information. So now, if there are no more questions, we can break out for take a break, a 5-minute break. And then when we are back, Claudia is going to start the first hands-on session, presenting how to create interactive maps and visualizing information in them. And during the break, if you have any problems logging in on finding the information, please let us know. We will be here. Thank you.
So yes, again, it is important that you can log in to explore data, and it's nice if you have those updated locations in that file we showed here. It's not if you couldn't do it, you still will see the result. So it is not. Yeah, not the end of the world. So I suggest, well, 5 minutes, or shall we say 10 o'clock sharp, we are back. And then we will do an interactive map. I will stay online in the meantime. So if anybody has any problems logging in, then please just let us know. See you at 10 o'clock. So 10 o'clock. I need to find where you guys are. I can't see you at the moment. There we go. So is everybody kind of back, or quite a few people?
Yes,
Yeah?
here.
Excellent. Again, this is now an interactive like workshop where we would like you to to do things, and you can follow on the screen as well. But please, if you have any questions, problems, please just ask us, let us know. Otherwise, it is not fun for you. So, and we would not like to you have not fun. Right. So you have logged into the Explore data server, and I'm gonna put this on my screen, which you should see now. So I'm on a different server just to lower the amount of logins. But what you should see is those folders, and we're gonna start with an interactive map. So I would ask you to go inside this map and open the exercise 1 map notebook. And if you do this, you should end up with a screen like this. And if just a few people could verify for me that that has worked, that would be very nice.
It works fine.
Good, excellent. And Carolina, can you keep an eye on the chat box? So if somebody has a question, then you can go into the chat as well. Thank you. So right, as Carolina said, on the top you see a logo. So this is a markdown cell. We have another cell down here, which is again a markdown. So which says, you know, this is just text information for you. On the next cell, you see this little arrow here, which you can run a cell. So this is now actual Python code where we import a library. So I'm gonna run this, and you will see a little star on the left side and then a number, and then it should have been imported properly. There is no output with that, but that's fine. And it is as simple as this one line here to create a map. And so if you execute this one, so we have now an object in Python, a map. You don't see it yet because you need to tell that you want to see it. So this cell down here, if we execute, it takes a little longer, but if you scroll down, you will see now a world map. And if you have a mouse with a scroll wheel, you can scroll to zoom in and out. You can use those plus minus buttons on the top left. And, you know, you can zoom in quite a bit. I'm gonna somewhere to Europe and just move in. And you can see with one line of code, you have an interactive map already where you can go down to like building blocks. So I hope that worked for everybody.
Yep, works fine.
I'm gonna move my mouse to the left to scroll down in the Jupyter notebook. So the next part obviously is how can we add a marker, because a map on its own is nice, but it doesn't do much. And so in this cell here, we add a marker with a location. And we say, well, if you click on that marker, we will have a text displayed, which is the Greenwich Observatory. So if we execute this one, and then I will go back up to this map here, and I will execute this cell to show the map again. And probably you're disappointed now because you don't see anything. So you need to scroll out a little bit, and then you will see that there is a marker now. And we can zoom into that marker. So you should end up in London, or actually in Greenwich. And this is the observatory. And we are sharing this notebook. Okay, that was not the plan. So I hope that everybody has seen this marker now. If not, please just tell us, talk to us. So the next part
Can
is.
you please repeat the steps, because I probably missed the start.
Okay. So do you see a map?
No.
Okay.
I don't see a map neither.
Okay.
I see the map, no problem.
So if you open this notebook, I think you're gonna, and you click this little arrow here, then you should get a number on the left side.
I cannot see the executor arrow next to
If
the
not,
cell.
then you can go on top here, which says run.
Oh, okay.
That is one option. So you need to click into it. You have a little border around the code cell, and you can execute it by clicking on run. Or alternatively, if you press Shift and Enter,
All right.
it will execute as well.
Yeah, that's fine. Thanks.
So the next step then is to create this map. And again, I'm going to execute this cell. Nothing happens. And in the show map code cell here, you see it on the green border. I execute again. And then you should see a map.
I cannot run the first step. I cannot take a number. I mean, I have reloaded the exercise, and I go to import libraries. No.
So you click with the mouse in here, and you have like a green border.
Yes, I have a green
And
border.
then you click on run.
On run there. Okay, I have a star there now.
Yeah, and then you get a little number.
Okay, now I have a number.
Yeah.
2.
So you do the same on this code cell here.
Okay,
with
run
my
again.
map.
Okay.
And then you do the same with show now my map.
Yes, I can see the map now.
Excellent. So every code cell you have to enter and execute.
Okay. Okay, now thank you.
So we have added this marker for Greenwich Observatory. We add now a second marker down here, which now is a different location and a different text. And for you who have a little bit knowledge of HTML, the text message is a pure HTML representation. So if we add a link in HTML notation, you will see that it is actually a link. So I have executed this cell here. I will go back up to the map, execute this cell again. And if we zoom out now, you see there is a new marker, a green leaf. And if I zoom in, you should end up in Lund, where the ICOS Carbon Portal headquarters is. And if you click on the green leaf, you have this new text and including a link which is going to our main website. So I will scroll back down again. And for you now to play around, as you can see, there is this icon defined here, which says, yeah, my icon is a leaf and I would like to have the color green. And I have put up some more things in the text above where you can change the icon. I just tested a few of them, like leaf or a glass or a cloud or things, and you can change the color as well. So please feel free to, change the icon as you like. And
can I have a short question?
Yes, please go ahead.
Is this workbook, Jupyter Notebook, shared, or are we editing each of us our own version of the notebook?
So this Jupyter service is running on Docker. So each of you guys, you have your own little box, so to say.
Okay.
So you run your own. You will not see others' work. Unless there is one option, if two of you have chosen the exactly same username by chance, then you may end up in the same instance. But no, it is your own workspace. So the last step in this exercise here is, and this is quite important because the exercise for the final presentation for you, where you need to send us some output, you can save this map to an ordinary file. So you have this map in here, which is called My Map, and you can say, well, save it, and you give it a name. So if I execute now this cell here, well, you can't see anything in here. But if you go back to where you have logged in, you see on top here, I'm going to switch back to this folder. Now there is a map HTML. And this file is a static representation of the map. So first of all, you can click on it and a new full screen kind of website opens with the map you have just created. And this is now completely independent of our service. I'm going to close this tab again. And you can, if you mark this, download this file to your computer. So I do this. You see now down here, it has been downloaded to my personal computer. And I will go into this folder here. So where you can see it has been downloaded, this is now my computer. And if I open it from here, if you pay attention, you will see that my computer has opened this file from my computer. So this has nothing to do now with ICOS or the Jupyter service or whatsoever. This is completely independent of anything. It is a static website you have created. You can send it to your friend. You can save it to your computer whatsoever. So this is just to show you that how easy it is to create the map, put on few markers. You can send this file via email to somebody. They can open this file and they have an interactive map. So I hope this.
Sorry, Interactive. Why interactive? It's just
Well,
image.
interactive, so you can, it is not an image. You can scroll in and out. You can click on the marker. It opens up a pop-up. There
Okay,
is a
that's
link
interactive.
inside. Yes,
Mm.
because usually it is difficult to, you know, like in a PowerPoint presentation where you put an image in, but you cannot do anything. You cannot scroll in or out. So that was what we meant with interactive.
Thanks.
So,
sorry, I
yes,
have a question.
please.
Thank you. Is there a way, an option to have a satellite map?
We will come to that.
Okay.
This is exercise 3. But let's go to exercise 2. I just wanted to show you a little bit more.
Another question, I hope a quick question. Is it
Please.
possible to add an array of markers in one single instruction?
Yes, so this is now exercise 2, which we start.
Thank you.
No worries. No, I understand those questions because I have the same questions. I just divided it up in smaller bits because a few of you people haven't seen a Jupyter notebook or Python code at all. So that's why I do it very slowly.
I have a question myself, if you don't mind. Or I was just curious why some people see the execution arrow next to the code chunks and others don't. I mean, it is also my case that I didn't see the execution arrow displayed next to the code, so I had to either press the
Shift
run
enter
button
or the run button. In all honesty, I do not know.
Because I mean, we are using, we are basing on Docker, as you said before, so it should be containerized and using the same operating system.
The only thing I can think of is that it is different operating system and different browsers. And the front end is all based on JavaScript. So the implementation of JavaScript may be different, but this is only a guess. I do not know, to be honest.
Yeah, I think
but I guess it is that.
Yeah, okay.
Another possibility is that it has to do with the settings that you have on your Jupyter instance. Like you can say if you want your code cells to be numbered or not, and that you handle within each separate notebook. So since Claudio is running this from his personal account, it might be a setting that he has put at an earlier stage as well. That's another possibility.
Yeah.
Okay, interesting. Thank you.
Good. So let's open exercise 2. So this comes now, hopefully, a little bit more as a fun part. So I will run a little bit quicker now. Again, we do a map, and we just import 2 more libraries, but this has to do only that we are now reading here this file you have filled out on the file share, which I asked you to put in the location where on your line. So we're going to read this now into our Jupyter notebook. So this is the link where you put in your numbers. I'm going to create a members data frame, and I'm going to display this here. And as you can see now, we have a table in Jupyter with the first name, last name, and so on. And here, there should be numbers with your latitude and longitude. And I cannot see any numbers here. So the problem, I would assume, let me go quickly back to this file. Yeah. I'm not sure why, but those are all with a comma entered instead. So it is not a number, it is a string. So I'm gonna change this
That's
first.
interesting because I have put it in with a point, not a comma.
I am not sure why this happened, to be honest. But maybe you can do it a little bit later on. I will show you the process anyway. So I have changed now. Lorian, I don't know if you are here or not, but
Yes, I am. I also copy
so you
pasted
see
it.
here now number 5
Yes.
is not a number. I have changed this now in the background, so I'm gonna execute this cell again and show the members. And as you can see, it's still not reading. So, but anyway, I will have a look afterwards. We have a few people here where we have a latitude, longitude. So as in exercise 1 now, we create the map and show the map. And by the way, I have recentered the map now to a little bit more Europe-centered. And so nothing is on the map again, but now we create markers again. And we do apply 2 different things here. One is the marker cluster, which you will see in an instant. And we have a loop here through all the members from that table you saw above. So for each member, we say, well, we take the latitude, we take the longitude, we take the whole row as an information, as HTML, and then we create a marker, like in exercise 1, where we say, well, put this marker on with the latitude from the member, the longitude from the member, and this info. And then we add all those markers in one go to the map. So I execute this now. And now if we look at the map again down here, you see there is a greenish circle with a number 5, and this is a cluster of markers. So if I click on this one, or you can zoom in, you see there is one somewhere in Germany here, and 4 in Lund. So if we look at this one, this is Ute, where she is currently. And if we look at the Lund ones, so I have to zoom in. Oh no, there's one in Malmö. So this is Ida. And you can zoom in again, and then at some point it will segregate the markers. And if I zoom out again, then they will pop back in. And so again, this is, in my opinion, very interactive to do.
Claudio?
Yes.
I have changed some settings in the files. Maybe you can rerun it again and it works now with the members.
Okay, I will. By the way, for everybody, if you run into trouble, there is something called in the kernel restart and clear output, which means, oh, let's just restart again because we have messed something up. So I will do this, and all the output of the notebook disappears apart from the code cells and the text. And all the numbers here you can see on the left side are gone as well. So I execute now from the top down again. I import the libraries, I read the members file. And now we have a look, and latitude, longitude still doesn't show up. Maybe it does in your case because I have a feeling there is a cache behind it, but never mind.
So for me, it doesn't run neither.
Either
So
for me.
only
Okay, I
I-
will have a look later on to make sure that you can read it, but you get the idea because those first 5 people, they have numbers here in latitude, longitude. So I will, when Carolina is doing her presentation, I will make sure that it runs. So in the last hour between 11 and 12, we can have a look. Again, you can save the map here. And I need to hurry on because we are running late now. Just one more thing. We go to, or have you any question to this? To the idea at least. That you can put in, many markers in a cluster on the map. So I will go to exercise 3, and this is now a little bit more important for you in regards to what Carolina will tell you afterwards. So what we have here is we do exactly the same, but instead of reading this members file, we will have a list of stations from the ICOS network. And this is just, again, with very, very little code. You will get the table where you have an ID for all those stations we run, including those Stilt ICOS stations, the name, in which country, latitude, longitude, and so on. For each station, you can get metadata, which says, okay, more information about this station itself. And again, I repeat this, but this is good exercise. We create the map again. And the same as with the markers for the members, we create this cluster here. But this time we do not run through the members, but we have a loop through the station list. We add the latitude, longitude. We create this info again from the one row, and add everything to the map. And if we do this, so now you see all the ICOS stations on a world map. And you can zoom in, click on it, and you have information about this station. You can zoom out again and so on. And as you see, this is, I don't know, 10 lines of code. But okay, so I have to stop here now to give Carolina at least some time. There is some more and fancy stuff in the exercise 4, and I'm more than happy to have a little go later on between 11 and 12, or if somebody has a question, go and have a look. It is not rocket science, so please just play around and have a look. And yes, I think I need to stop and we need to shorten our break.
Claudio, before we do that, there is a question by Diego who wonders if it's possible to remove a marker after it has been added to the folio map.
I have not tried that. I need to look it up. I think rather not. Well, no, it has to be possible. but you need to keep track of the object itself. It is probably easier to recreate the map without the marker.
And I have another question, sorry. So to use Jupyter Notebook, so you should be able to write Python, right? So you should have some idea about Python.
About Python?
Yeah, to write the code.
Python, yes.
Python.
Yeah.
Oh yeah, well, yes, true. But as you can see, Python is very easy to learn. That is one thing, and you need very, very little code to create, this map here. But yes, you need to invest a little bit of time to learn Python. I agree.
And one more question from the chat. Lynn wonders what the difference is between adding 2 markers and making a cluster of 2 markers.
The cluster does automatically put them together. If you think of, you have 92 markers, I hope you can see my screen. So
yes.
if you would have those single markers, 92 of them, trying to display on the map here, that is going to be extremely messy. So the beauty is that it just puts them together in a single thing. That is the only difference. You would just, without the marker cluster, you would just have many, many markers. I will try. Let's do it. Let's say hang on 1 second. It is actually a very good question because it looks then really ugly. So we will say we add the marker directly to the map and we do not this clustering. And we don't need this. So I'm gonna create the map again.
Ciao.
Okay, I need to.
Claudio, your kernel has, yeah.
Okay, so I will run this again. And let's see what happens. So this is the result without the clustering. And yes, you can do it obviously, but it makes everything very busy to look at. So personally, I like the cluster, but yes.
Now it's evident what you mean by interactive. Okay. Interactive.
Yeah, well, in interactive programming, this is what I just did, and the map itself is interactive as well, yes.
Last question, sorry. Is there any, because you need to know which libraries to use and so on, which is the best step if one would like to work with it and learn it? Is there a good material to understand?
Oh, there is many things online. And thanks to Carolina, you will find, if you look at your login, you have started about with this one. So there is an introduction here, which is a quick start to Python, which has links to more online and so on. So have a look around here. There is many examples which you can follow and get started.
Thank you.
And you know, those examples we have here are tried to be very simple, so you can follow even if you don't know Python. But yes, so I have used up
One more question,
way more
Claudio,
than
sorry.
yeah, I'm fine with it. I'm just going to take it.
It's from Salvador, and he's wondering if you have many points, for example, a few hundred, will then the map render extremely slowly but still work, or not render at all?
Sorry, here more than a question, it was an affirmation because I have tried this before, and I know if you have many points, it's depending on your machine, I guess, but sorry, it might even not work if you have many points.
Yeah, well, as you can see, the map I just did for you guys here, those are 100 and whatever. How many do we have? 124 markers, which renders, you know, reasonably fast, I think. But yes, obviously, at some point it gets slower and slower, and maybe at some point it will stop working. That's why I personally always use this cluster function, because it's just easier for the computer and easier to deal with visually as well. So if we don't have any more questions, or please keep your questions, but ask me like after Carolina's presentation, because otherwise we don't have time. So I don't know, could I ask you, and please give me an honest answer, would you like to have a break, or shall we continue with Carolina's presentation? Just unmute yourself and say something.
Well, according to me, we can go on.
Fine to continue? Okay,
Yes,
let's do it the other way. If somebody has objection, then unmute yourself and tell us. And if not, I'm gonna stop sharing my screen. And Carolina, it is all yours.
Thank you, Claudio. I hope that all of you can hear me now. Is the sound okay?
Yes.
Yes, okay, perfect. So, do you all see my screen? Could I get a confirmation?
Yes.
Yes, it's big enough? Okay, perfect. So, welcome to this part of the hands-on session. In this notebook, we are going to roll a little bit back again to what Ute and Ida presented earlier. And more in particular, we're going to explore different ways of accessing, processing, and visualizing time series of data along with its corresponding metadata from ICOS Carbon Portal. The focus of the module is to access ICOS data and metadata for CO2 concentrations measured at ICOS atmosphere stations, as well as simulated CO2 concentrations from the Stilt model that Ute presented to you earlier. Data and metadata will be accessed using a specially designed by ICOS and Claudio Python library. Throughout the different steps of the notebook, you will have the possibility to get a glimpse of how ICOS deals with data provenance. That is how fair ICOS data are. and get some ideas on how to utilize metadata information in data analysis processes as well as in data visualizations. Here you see the different parts the notebook is divided into. So we are going to, as I mentioned earlier, explore what atmospheric stations ICOS has and where they are, so where the data comes from. Then we are going to look into how to import all the necessary Python modules that we need to run this notebook, as well as the code that we have developed at the ICOS Carbon portal in order to process our data. We are going to use these tools and libraries to access the ICOS observations. We are going to process them, plot them and see how they look like, create some aggregated statistics with the help as well of metadata. And finally, we are going to access the simulated CO2 observations, so accessing the Stilt model output, and compare that output to the real measured observations. So let's start here. First, we want to get an overview over where ICOS atmosphere stations are and what are the surrounding areas that affect the measurements, like Ute and Ida showed in their presentations. And also what other stations are nearby if we want to do a study, etc. So in order to do that, I'm going to click on the link and be redirected to the ICOS homepage. I will go to observations and then atmosphere stations. Scroll down, and here we have an interactive map which is created using well, the same basic software that Claudia showed you earlier, but this is then just pure JavaScript and JSON objects. From the interactive legend, I'm going to select to only see the atmosphere stations. And now you see we have a physical layer, but we can also choose a different base map, like the OpenStreetMap. And then we see in what cities other stations are located in. And as the exercise is focusing on data from Garto, which was the station that Ida also showed in her presentation, we're going to zoom in here and then change the base map to imagery to see that if it really is a station. Here, yes. If you hover over the marker, you will get some metadata that is related to the station. This is just a subset of the metadata for the station, but nevertheless, you see what is the three-letter station code, which is GAT, the country of origin, the site type, it's a tall tower. And yes, you can see in the map that this is indeed a tall tower. And the measuring instruments are then positioned at different height levels of this tower. We are going to take data 340 meters approximately above ground level, so near the top probably of this station. And we see the name of the station PI. So if we now go back to the notebook, you will see a list here of stations. So as an exercise, when these hands-on sessions are over, you will be asked to repeat each and every step of the current notebook, but for a different station. So here you can select from one of these stations, and you have some information that you need to complete the exercise, like the station 3 coded ID, the sampling height, which is the location or the altitude above ground level at which the measuring instrument is installed at. And then you need to know the corresponding Stilt ID for the same station. And you get also the station name, the full name, just for matter of reference. In order to run the notebook, just like before when Claudio imported the library called Folium so that he could create the interactive maps, here we're going to import quite a big list of Python modules in order to be able to execute the following parts of the notebook. I'm not going into details about what each one of the libraries does at this stage because it's not important. It's the processing step at this for this webinar. And then here are also some examples of how to import modules that you yourself have developed, or in this case, we at ICOS have developed. And call from different notebooks in order to support our data processing and data visualizations. So I'm going to execute this cell. Now you see it's been executed and it tells me that our interactive library also has been loaded.
May I ask, should we also try it out now or just follow you?
Yes, please follow every step that I take as well. Yes.
Okay,
thank you for the question.
Fast now.
Probably
Okay.
Yeah, you need to slow down, Carolina.
Okay.
I just identified that you are in a still time series, and then what do we have to do?
Well, it's not at this stage. Now we're going to go through the notebook together. You don't have to do anything rather than more than executing each one of the code cells as I go through them. And you are free to interrupt me and ask questions at any point. When this hands-on session is over, then you will do an exercise by repeating the steps and doing them for another station than the one that I have in this example. Okay?
I have a quick question.
Yes.
Just for the modules from ICOS, the import line is just from ICOS, CP, station, etc. So it means that the Python notebooks knows where to get the module from.
Yes. So okay. When you it's a little bit more complicated question than that. There are multiple ways of doing this, but in this case, for the ICOS CP library, and Claudia, correct me if I'm wrong, you're more of an expert in that than I am, is that this library has been installed when you create this Jupyter instance. So we have a Jupyter service in which we have that lives inside a virtual machine and is spawned by Docker files, where we have specified which libraries should be installed for these Jupyter instances. And including in these libraries.
Sorry to interrupt, which is all true what you're saying, Carolina. The main point is there is an official package available on pypy.org. So anybody with a Python can go to pypy.org, look for ICOS CP, and you can install the library as you do with a pip or conda install. So it is all public available and you can install it. Obviously, we have installed it in our service as well.
Okay, thanks.
Okay, but then of course you can write your own libraries and modules and then store them externally, like here, in different folders and call them from your notebook. That is another way. But if you have a more stable version of your notebook, then you prefer to package it up as a module and add it to PyPy, like Claudio said, so that other people also can download and use your library. And you can get feedback on how to develop it further, etc. Yes. So now we want to explore what kind of data you can get, but also to get access to CO2 observations from the ICOS data portal. In order to do that, here in ICOS, we have implemented PIDs, which are unique persistent identifiers that identify uniquely each data object. And in order to get that unique persistent identifier, we are going to have to go back to the ICOS web page. And this time we are going to go to the data portal, so data services, and then data portal. And when we click on data portal, we will be redirected to the data search interface. And here on the left side of your screen, you will see the search interface. In the theme, we pick atmospheric data because this is what we are working with today. In the station of origin field, we are going to select the station that we are going to use in our example, which is Gartow. And the sampling height will be 341 meters. And then in the data type, we are going to select the CO2 concentrations, which are included in a data product called ICOS ATC CO2 release. So if you enter this information in the corresponding search fields, you should be left with only one option in the results panel. Have everyone been able to follow so far? If I can get a confirmation. Yes, okay. So now if we click on this link, we will be redirected to the data product landing page, or data object landing page. And here you will find the persistent identifier identifying this specific data set at the top of the page. The page also includes additional metadata information describing this data object. So like you have a title about what it includes, a citation for the data set, which is very important, and you will see how we can get access to that later on from within the notebook as well. You have the file name, and you also have the possibility to view previous versions of this data set. So this is quite important. And then the PID for the previous version will be a different one compared to the current one that we have today. And this is very important in case a researcher or a scientist has performed some processing over a certain data set and got certain results, because then would then only depict this information for one point in time for a specific version defined by the persistent identifier of that data set. So that is a way of keeping track and making sure that we are fair. So if we copy now this PID and return to the notebook, we will use the ICOS CP library to enter this piece of information here as an input parameter in order to get access to the data included in this data object. So I'm going to execute now this code cell, and a data object with this information will be created. In order to see what is included in this data object, you can type the name of the variable in which it is stored in, and then point, and then click on Tab. Can you see now that there is a drop-down list here?
Or is the key on your keyboard, the tab key?
Yes.
Just
Which is usually just above caps lock. So if you click that, then you will get a list of attributes and methods that are related to this object. And in other words, this is kind of what kind of information is included in this variable. Just see it like that if you are not that familiar with objects. So
Sorry, how to get to the displayable?
okay, so you copy the name of the variable and then you paste it. And then you click on dot. And after that, you click on your tab button, which is usually located above your caps lock button on your, see? And then it takes a little while, and then you will have a pop-up with the available methods and attributes related to this object.
The mouse tapped by something else. I can't have the drop-down list.
You cannot see it, or?
The mouse action is trapped by something else. I can't have drop-down list. Is there another way to get it?
No, this is the way of getting it. Yeah. Otherwise, you can try.
you have, sorry to interrupt, you have to first execute it once to create this digital object. So it is better if you...
Yeah, I did it already.
Yeah, and then if you press if you write the dot like in another programming language in the tab key, it takes a while to populate the list. But anyway, all those information is available in the documentation of the library as well.
Okay, I'll go for the documentation. Thank you.
Yeah.
And maybe at the end of the session, we can also show Claudia has developed quite nice guidelines of how to get started using this library. And there you will see all the examples of what is available and how you can get access to it.
The job down list also doesn't work for me. I think maybe it is caused by if we install some extension for this job notebook. So because we are not installed some extension for the job notebook, that's why we cannot use the dot and the tab key to see the job down list.
Well, I don't think it's related necessarily to that. It's just that depending on your PC, I mean, this can take quite some time to appear. But it doesn't matter. If we move on now, you will be able to see some examples of what it includes in the coming parts of the notebook.
Yes. Thank you.
Thank you. So if you, yeah, now we want to get access to the data included in this data object, and we can do that by writing the name of our object and then dot and call the data attribute. And inside the data attribute, we will see a time series for CO2 concentration observations. And this is then stored or returned in a data frame. In Python, it's called a pandas data frame, which has some indexes. We see here the first 5 rows in this data frame and the last 5 rows. At the bottom, you will see the total amount of rows and columns. So we have about a little bit more than 35,000 rows and 5 columns. And the columns are then the values for the CO2 concentration, at which point this concentration observation was observed at. That is what is included in the timestamp variable. And we have another column for quality flag. So different values for the quality flag column indicate the quality of the measured observation. And then we have the total number of points that were used to produce the mean or aggregated CO2 concentration for 1 hour, and the standard deviation of that value. So if we now move forward, you will see how it is possible to filter this data frame based on the value of a quality flag, so based on the value of an associated metadata information. To do that now, so you see here a list of the different quality flag, let's say codes, and then a description of what they mean. So now let's say we want to only see data that is correct after manual quality control, and that is capital O. So if I enter that in my code cell and then execute it, I will only see a subset of the rows in the data frame for which the data quality flag is O. So is the data correct after manual quality control? And as you see, it returns 31,000, well, almost 32,000 rows in comparison to the 35,000 rows that our initial data frame had. We can try and see, okay, do we have bad data that was so data incorrect after the manual quality control that we would like to not include in our further processing? And we see that we have quite a lot. And if we want the exact number of that, we can ask len, which stands for length. And we see that it is 50 rows that have bad quality data. If I now take out the CO2 column name, I will get all the data rows that have, so all the columns for which the data quality flag has the value K, and we see that the CO2 value have been filtered to be none. As I said, we are only going to use the good quality data. So next, we're going to explore briefly what other available metadata this data object that we have loaded includes. So we have, let's say, 3 different categories of metadata available. If you execute the first code cell, you will see some information regarding the data file where the information is stored in, like the total number of rows in the data file name, and what the name of the data product that it represents. Next, if we execute the next code cell, you will see metadata regarding the data content. So like, what are the column names? What is the value type for each one of the column names? What is the unit for the values included in every column? And all of this information is very interesting in order to use either for filtering your data or maybe to include in your visualizations for later, or as an information to, if you need to harmonize data, to take into account what unit it is if you want to use it together with other data sets. And the last category, let's say, of metadata would be metadata that is associated with the station the data has been measured at. So here we see that the station name is Garto, the station 3 character long ID is GAT, the sampling height is 341 meters above ground level. This is where the measuring instrument is positioned in the tower that we saw earlier, and the longitude and latitude of the station, as well as the elevation above sea level that the station is located in. and that this belongs to the ICOS atmospheric dataset and not ecosystem or ocean. Now, since we have gotten our data, it would be nice to get an overview of how it looks like. And then, very simple, just by executing this line of code, you will get a quick plot showing CO2 concentrations from Gartow in northern Germany between the years of 2016 and 2020. So the only thing that I need to do in order to produce this plot is to give the data object name, then specify that I want to use the data from this data object, and then use the built-in, the pandas Python built-in method called plot, and signify that I want my x-axis to host the timestamp related values, so this column name, and my y-axis to include the CO2 concentrations. This is all you need. You just execute this and you get a plot. But as you can see, the plot is quite simple and it doesn't include a title or a label for your y-axis. It's just a timestamp and the graph. In order to populate your plot with more details, like the y-axis label and the title, you can use the metadata that you saw before to do so, the metadata that is related to this data object. So, like before, I call my data object, I say I want the data, and I use the built-in method plot. You signify which column names you want to be plotted, and then you add the parameter title, and you filter the data frame including the data object name together with the station information and the sampling height, and include that through Python's string concatenation operator, which is the plus sign, to produce a string for your title. And then you do the same. Well, you extract the unit for the CO2 concentration from your data object metadata for your data. The plot is quite small, so in order to view patterns in it, it's good to adjust the figure size, and you can do that by adding one more parameter inside your plot method and signify the extent of your new plot. So now you will be able to see a larger plot. And in order to be fair, we need to provide proper citation for our dataset that uniquely identifies this version of it. And you do that by calling the data object and the citation attribute. And here you have it. At ICOS, we have also provided interactive plots showing all of this, or created code for providing interactive plots showing all of this information. So here is an example using the Bioke visualization library. And if you execute this code cell, you will be able to zoom in to the observations, click on different tools in the toolbox at the right side of the plot, like hover. And now for each one of the measurements the measuring points that you have in your plot, you will be able to extract the exact information about when this observation was taken, at what time, sorry for the drilling, what is the quality flag for this information, the number of points used to produce this aggregated mean value, and the standard deviation. And you can also select to save this locally to your computer, if you so would wish, and return it to its initial state. So it's a nice thing to kind of play with and for your target user groups to identify areas of interest, zoom into them, and further explore them. Any questions to this part? If not, I can move on. So now we would like to analyze these observations. One quick way of getting a good overview of the values in your data set is to use a built-in method called describe, which gives you the aggregated statistics for the values of a certain column. And here we see how many values that we have. So this is only showing the, let's say, the good values. The bad values have been filtered out. They are not included in this. We see the mean value, the standard deviation of values, the min and max values, as well as the value for the first quartile or the second and third. Another thing to do if you want to further process a time series of data is that, as you saw before, if I now scroll up a little bit, the index for your for inside your data frame was a numeric index, and you can select and extract information from this data frame based on this index. But when you're dealing with time series, it's more interesting to do so using time as index, because maybe you're interested in a certain time period rather than knowing with the number of the index that corresponds to a specific time period. And in order to be able to search by time, it's a good practice to assign the column including time as the index of this data frame. So if I execute now this code cell, you will see that instead of having a numeric index, you have timestamp. That is time as your as the data frame's index. And what you can do with that is that you can, for instance, decide to calculate monthly means of your data. And then you do that by grouping your data into monthly groups. And to do that, you use the resample built-in method from Pandas and say, I want my data sets to be resampled by month. So you use the keyword M. And in these monthly chunks, let's say, of values, I want you to calculate the mean. And drop now means that I want my code to disregard any non-values in the column. And the next line of code actually assigns the monthly calculated mean to the mid of the month instead of the start or the end. So if I run this, I will get my monthly means. I can add a code cell here. And here you can see that I get the monthly mean for the month of May, for instance, here, and it is assigned to the mid of the month instead of the beginning or the end of it. And here is the calculated mean value. I can do the same thing for, repeat the same process, but now calculating the standard deviation instead of the mean. I can add here a code cell and show you the result. So here you have the monthly mean, which is again then assigned to the mid of the month.
Excuse me,
Yeah.
one quick question. How do you add a code cell?
Oh, so if you have selected one code cell and you want to add one under it, you go to the toolbar here and press on the plus sign. And then you have a new code cell.
Okay, thank you.
Another way is also to go to edit and, to insert and say insert cell above or below. Now I'm going to move on. So now that we have calculated our monthly means and monthly standard deviations, it would be nice to plot this information and see if we can see any trends. So if you execute the next code cell, you will see a plot with the monthly means in the dashed line and the standard deviation as the shadow line. And then use again the metadata to populate the title field and the X and Y axis labels. Next, we are going to try and access the Stilt model output. And to do that, we first need to get a variable and assign it with the corresponding Stilt station ID for the station that we looked at the real observations for before. And we're going to only extract the, let's say, the record for the same time as for the one we have real observations for. So if you execute the cell, you will be able to extract the Stilt information. And what we are interested in here is the column with the CO2 concentration, which is what I have highlighted here. And here you see, just like when Ute presented, that the information is presented in 3 hourly time steps, but the observations that we have from ICOS is in 1 hourly time step. Before we do anything about that, we're going to plot the Stilt time series, and we see that here we also have a pattern with high values during the winter time and early spring, and then lower values during the summer and the early autumn. And that's due to photosynthesis taking up CO2 from the atmosphere when we have plants around and enough light. And the opposite during the winter months and early spring before photosynthesis begins to Now we would like to compare if the simulated values are similar to the observed values and see how well our model has performed. So one way of doing that, first step, visually inspect how well they fit, and we can do that by creating a plot, like here. So here you can see that they fit well, rather nicely. But in order to be able to determine that in strict mathematics, we need to do some more operations. I'm going to go through a little bit faster through this, just to have more time with questions and what we need to have in the next part. So before we start processing these two datasets together, we need to harmonize them and make sure that they are in the same units and that they are in the same time intervals. So they are in the same unit, but the problem is that the ICOS observed CO2 concentrations is in 1 hourly time step, whilst the Stilt model output is in a 3 hourly frequency or time step or interval. So here, what this code cell does is that I am going to only select the value that corresponds to the same, let's say, time point where the simulated value in Stilt is taken. So you see here, I'm selecting the same time point as which as for these values are included for in the Stilt model. And I save this in a separate data frame. We run the cell. Now that everything is harmonized, we can subtract the simulated CO2 concentration observations from the real ones and see how much they differ, and then plot this difference. Here we have a plot of it. We see that there are some time points during which the difference is larger and others where the difference is smaller. If we want to examine this in greater detail, we can plot it in an interactive plot where we can really zoom in and see during which day and what time point exactly the largest difference between the two data sets are observed. But the question is this really a good fit? Does the model provide a representative simulation of the real observed values? So the first step to answering this question is to use again the built-in method describe and get an overview of the aggregated statistics in the difference that we calculated before. And another thing that we could do is that we could test the correlation between the simulated CO2 observations dataset and the observed CO2 concentration dataset. So again, the Python Pandas library has a built-in method called cor, which stands for correlation, where you can define the two data frames that you want to compare. So here is the first one with the real observed values, and this is the data frame with the simulated ones. And you can add which kind of correlation method you prefer. We run this cell, we get a positive result that is close to 1, which indicates that we have a quite good correlation and that our values are linearly correlated. So it is a good fit. And then as a last, I put this code cell just for the purpose of the exercises later. If you execute it, you will be able to see the name and the sampling height information for the observed values as well as for the simulated values, just to make sure that you have not kept the simulated observed values from the Garto station and then maybe done this extracted the information for the Stilt observation simulated values from another station. And when you submit the exercise, make sure to double click on the markdown cell here and change, well, add your own name and affiliation. Yes, that was all from me for this part. Are there any questions?
I have one question, generally speaking, about Jupyter notebooks. So do you think you could obtain similar results, but instead of using Jupyter notebooks, by using something provided by R, like R Markdown documents?
Yes, definitely. So Jupyter, the name Jupyter is basically an abbreviation of the languages Julia, Python, and R. So Jupyter notebooks are also available for the R language. Mm-hmm. So you can do exactly the same by entering R code in the code cells and running it within a notebook. If you have installed the R language to your Jupyter instance. For example, here, if you go back to your working folder and click on New, you can select to open a new notebook in one of the languages that are installed here. There are, I don't know, almost 100 maybe languages that are available to be rendered within a Jupyter notebook or within a notebook environment. It depends really on how you set up your service. So here we have one for R. I can test and open one. And now you can write code here in R and execute it just like you did with Python before.
Yeah, I see.
May I add that we have installed Julia and R out of the box. So there is no additional packages or things installed. So you're on your own. We do not support at the moment our notebooks, but please feel free to do our on notebooks.
I mean, usually people need to make a choice between Python and R when it comes to the functionalities that you would like to use in your work, but that makes sense.
I agree, and we went for Python.
Yeah.
For the
Yeah.
moment, at least. So yeah.
Mm-hmm. Yeah, I mean, so
but
in
again,
to...
you know, the Jupyter interface is just a you can think of a JavaScript front end, and in the background there is a kernel executing code.
Right.
So you can even write your own kernel for a language. You can use a MATLAB kernel if you then have the license for MATLAB, for example.
Mm-hmm. Yeah. And we are
because
doing
every notebook is exported as a JSON object and then is read by JavaScript, so it doesn't really matter.
I see. Yeah, now I get the general picture. Thank you.
I have a question. It's not really related to the presentation you did today, but more related, associating with what we learned yesterday. How does the ICOS does the ontology? Which program do you use to store the database and all the relationships? How is it done?
Shall I go, Carolina?
Yes, of course. I will just stop sharing. Okay.
In the background, there is a triple store. So it is a RDF ontology-based triple store. So
can you write the name in the chat, please? Could you please write these names on the chat?
It is a
okay.
OWL ontology based on a triple store. I forgot the software exactly, and then creating the semantics or the ontologies itself. Most people here use Protégé. I think that's the software you looked at yesterday as well. So it is exactly the same setup. And by the way, maybe I can, yeah, well, it goes much further, but if you have this ontology based on a triple store and everything, you can have a Sparkle interface to extract any information you like. But you need to know how Sparkle works and everything, but we have this interface available.
Okay.
I'm not sure if I really have answered your question, but
yeah, you did. And now it's just a curiosity, because we are like, as a postdoc, I'm compiling and doing my own database, right? How long did it take for you guys, like from the moment you start collecting the data from the measuring stations to the stage that you have today, that everything is like, looks really, really good and interactive and all free? And how long did it take, the whole process?
it never finishes.
But to where you are today? Like from when you started, from where you are today, how long did it take? How many months, more or less, that you just have an idea, like the time and the investment you need to get to this point that you guys are today?
I honestly, I cannot say. you know, developing the metadata itself, the ontology, how you store the data or how you relate data to each other, that can take from a couple of days to a couple of months or even years. But then again, you start somewhere, and and then something will change and you have to adapt. Sorry.
Yeah, so this is Maggie. I also work at the Carbon Portal. You could say that we more or less started in January of 2015 to really with the details of the development work, and then we've implemented things step by step. Of course, starting with the ideas about how to organize or structure our metadata database and which entities to use there, etc. And then as data started to come in and we received data from the stations and also from the modeling community, we realized, of course, that we needed to make some changes and modifications and update things. But I would say that we had a working environment maybe after, which was more or less complete after 2 years or something like that. But we are always, as Claudio says, improving things and adapting to serve our end users in the best way. But it's not something that you do from one day to another.
So the easiest part in this whole setup is actually the virtual research environment. So setting up the Jupyter Hub and the login for the users and allowing people to do their own calculations, that is almost out of the box, and within a couple of weeks you can implement that. But storing the data and having a proper good interface for the data, that takes time. So I suggest I go very quickly, I promise quickly, back to 2 slides for the exercise, what we thought you could do in your time. This will take only like 2 or 3 minutes, and then we will stick around for another half an hour for any more questions you have. So let's go to full screen here. Yeah, as you probably better know than me, you have to hand in something or do something on your own. So what we were thinking of is that you do a map, as we have done in the first exercise, where you select one of the ICOS Stilt stations, and you can, for example, center the station, the map to that station, make sure that if you click on it, the information available is towards that station. There is a notebook where it shows you can change the base maps as well, and then you save this as a HTML file, as we did in exercise 1 or 2. And then you can send us this map to this email address. You will have this email address available afterwards. And secondly, that you go through that notebook, which Carolina showed you, and basically you just repeat all the steps there, but you select a different station. So it is not that you really have to write code, but you change the station, you run all the code cells, you look at the data, and you tell us at the end if you think that the model would correlate nicely to the observation. And then you can download this notebook with the HTML map for the same station and send it to us. Yes, please do append your name and affiliation in the file name and inside the notebook, so we know where it comes from. And very, very important to know that if you log out of this Explore Data Jupyter notebook you have open now, or if you do not anything, you will be kicked out and you will lose your work. So if you work on it, make sure that you download your work or your notebook. Otherwise, it is lost. So as a conclusion, maybe just from a user viewpoint, we think it is very user-friendly, easy to learn, it is easy to share, and you can write documentation and code at the same time. And so in the end, we think this is all building blocks towards a more fair data policy. Because if these steps are not easy, then you will never be able to create a fair data portal. And as you have seen with Carolina, there is plenty of metadata available, like the citation, you have the metadata about the station, where the data is coming from, and so on. So this should, in an ideal world at least, lead to more fairness. From the back-end viewpoint, we have opted for this setup. As I said before, it is kind of easy to deploy. It is almost out of the box. You can customize and adjust whatever you like because it is all open available source code, JavaScript, Python. So there is no border as what you can do with it. And in the end, there is a big community which allows you to have a low maintenance approach, I think. So I think that was quite a bit we have pushed into your brains. I really hope you learned something and you enjoyed it, hopefully a little bit. And as I said, we are here at least until 12 o'clock. So if you have any questions, please shoot. And even for later on, you know, drop us an email if you're completely stuck or if you want to have more information.
Hi, sorry. This is Salva from the Plant Management Institute. I have one more question. It is about how do you update the datasets? So I saw you have these datasets. I want to understand them, how you do for reproducibility, because it seems very interesting. So you have different dates, right? So you have, so for example, these datasets we were using from 2016 to 2020. So how do you do if you get new data? Could you add this new data to this dataset having the same DOI, or could you add a new dataset with a new DOI?
You mean in the background now, not for the notebook?
Not for the notebook. We selected a dataset during
the data portal,
using
the website.
Yeah, in the data portal, yes.
Yeah. Well, this depends a little bit, but usually there is a official release of data, and I think for the atmosphere data, like the CO2 concentrations, for example, there is every year a new file. So we create one PID, one unique identification for 1 year of data. But you know, this is dependent on a lot of things. We have PIDs as well for longer time series. Yes, but usually if we say, okay, this is a fixed time period, we have quality assured, quality controlled data. Let's get the PID to this 1 year, and that's it. That will never ever change again. If we do change for whatever reason anything inside the data, there will be a new PID. But this allows to So if you write a paper, if you do an analysis, and you refer to this one PID, we can guarantee you that you will end up in the same data set. Possibly, there is an update to this data set, which then gets a new PID. But if you use this one PID, you will always get exactly the same data.
Okay, thank you. Yes, that's a very good approach, actually. Yes, thank you.
So does the Carbon portal not have any more online data? So sort of that it's streaming as early as possible from the measurement station?
We do. Maybe I'm gonna share my screen. And people from the Carbon portal, just interrupt me or add if you want. So on the data portal here, well, there is plenty of data available. And what Carolina showed you was here the data level 2. So this is quality controlled released data where we think this is the best high quality data we can offer to the public. But we can remove this filter here, and we can go, let's say, to near real-time data for CO2, for example, from the atmospheric stations. So you see now here, if you look at the date, we add every day data to this file. So this is, if we look at this data, I open this one and I go to the preview, and I can select CO2 concentration. So you see this goes to yesterday or 2 days before maybe. But then this is not an official release and not quality controlled to the best of our abilities. Was that what you asked?
Yes, thank you.
Good. So, well, it seems like you don't have more question. Well, either you can work on your exercise if you like, or the other thing is I could very quickly show the interface to the station characterization, which Ida touched upon. We could go through the exercise 4 from the maps, which we didn't have time. Talk to me. I am easy. I don't have to do anything.
Could I ask one more question, which maybe can't be answered fully? There are 2 module files in your open directory here under time series modules: Stilt data py, and Bookiefuncs py. It seems that much more code is related to the output of this Jupyter notebooks than the code in the Jupyter notebook itself, and most of it seems to be in these modules. Is that so, or is that a wrong impression?
No, you're quite right. The thing is that those are specific functions written in Python. We use a lot. So we have one file which we import and use as functions.
Mm-hmm.
The same goes if you say import volume, for example, on the top of your notebook. In the background, there are many Python files loaded, which gives you a functionality.
Okay.
But this is the good part in Python. You can very easily write your own Python file with a few functions you like. You store them, you import and use them.
Okay. And a technical question. I tried to run the Jupyter notebook locally. Maybe I have to. I'm not familiar with doing so, but I got an error message that it doesn't seem to be a JSON file or somewhat. Only if you should have some some notion why this error message appears. If not,
so did you install the Jupyter Hub locally?
Yes, of course, yes. If the Jupyter notebook environment starts and I try to load these notebooks, and then I get this error message that it doesn't appear to be JSON. But if you have no notion at the moment, then I will go into it myself later.
Yeah, well, maybe this is a good point to, I'm going to share my screen again.
Show how to download the notebooks.
Yeah, exactly, yeah. So, because this is important for your exercise as well. Yes, I will show you the map we were unable to see because there is a caching issue. So I have opened this one map for where we read the members file. And so this is the map we tried to have with all the members here. And so if you're in a notebook like this, you should be able to go and say File and download. Oops, as notebook. And if you do this, then you should be able to run the notebook locally as well. However, there are two things which are possibly the reason when it does not run. One is that you don't have all the libraries installed. And the second one is that the notebook which Carolina showed, reading the Stilt results, that will not work locally. Because the Stilt results, as Ute showed you in the presentation, they can be very big. We are talking about terabytes here. So at the moment, it is not possible to read this data from your local computer. And for your exercise as well, so if you do everything and you say download as notebook, you see now down here, there is a notebook downloaded, which is on your computer. And this is the file you can send us. And please do add your name or something in here so we can recognize where the file is coming from.
How do we send it to you?
Ideally, Where was it? Here.
How do we send a file to you?
Ideally with an email.
Okay.
And again, remember that if you work on it, please download the file immediately before you go onto a lunch break or do something else, because otherwise it might be lost.
So may I just say something as a feedback? Is it okay that I say?
Absolutely,
So,
yes, sure.
So I must say that I had to choose either to listen and to follow the time series exercise or to do it on my own. So it was not really easy to do both. So, but I think I got enough input so that I can do it on my own and understand it. But yeah, it's a bit hard to do both, you know, follow.
And it is a lot
I agree
to
with
take
that, yeah.
in. Yes, we know, and especially if you're new to Jupyter Notebooks, you're new to Python, and then you're new to the content itself. So it is a lot. Yes.
Yeah, I was not new to Python or so, but it was a lot of content, and you look, and then I have one screen, and look and understand and do it on my own. So I will do it now, I think, and will discover some problems potentially, and then I come back to you and write an email if I have a problem, I think. So there will be questions, I'm sure.
We hope so.
Of course, you're welcome to write an email, and we will also be present during Friday for questions if you have any related to the exercise.
Yeah, but I think it was a great presentation, so thank you very much. I learned a lot.
Thank you. Thank you.
Well, I agree, but if you should still have some minutes time, I think it would be nice if you could tell us how to get at these Jupyter notebooks for station characterization, which you offered before at the start of the presentations. Do you know what I mean?
I do, absolutely.
So one important point is here that the presentation that we showed this morning should be available to everyone. I don't know if this is the case, but we have all the links in the presentation so that you can even afterwards go back and have a look at everything, because the things will be available. But now, Claudio, it's your turn. Sorry to interrupt.
No, that is fine. Well, I sent the PDF to Lucia. I'm sure she will be able to upload it to the
yes, I've just read
Lifewatch.
the slides are already online in the training platform, so you can find everything there.
Excellent.
Thank
yeah.
you.
So if you, it looks a little bit different on my computer, but if you go back to the initial files you have when you log into Explore Data, I hope that you see these folders. And you have been working in the project Jupyter Notebooks now in the ENVRI. But if you go back up here to the home, and then you go to the ICOS Jupyter Notebooks, then you should see a folder called Station Characterization. And I need to switch because this is not right. Sorry. I will do it like it looks on your side. Okay, so in the ICOS Jupyter Notebooks, you will find this Station Characterization folder. And there is the Station Characterization notebook. And if you open that one, it should look like this. And what you have to do is you execute those two code cells. And this is, by the way, a showcase as well. You know, talking of doing interactive notebooks. So you can create a complete application in a notebook. So we have created here a graphical user interface, which allows you to say, okay, let's select an ICOS station. Hilte Mossa, we want to look at Stilt results from...
Sorry to interrupt you, but it doesn't work for me. After the import GUI, nothing happens.
Did you give it a couple of seconds?
Yes.
So did you get the number on the left side here?
Yes. So
And
it's
you can-
already 5 because I tried a few times. So.
Okay, that is strange. Does anybody else has tried just now?
For me, it works. Works fine.
For me too, it also works.
Maybe if we restart the kernel for this case where it doesn't work. If
Okay,
you can show that, Claudia.
Yeah, so if Barbara, if you go to kernel, restart and clear output. So then you should end up again like with the initial state of this notebook. So I'm gonna execute this first cell. And
now it works. I cleared it and it works.
Okay, yeah. This is one of the things in Jupyter notebooks. If you're stuck, always try this kernel restart and just, you know, restart your notebook. But good. So I'm gonna select now a station. Oops. Let's take. Well, doesn't really matter. Hopefully, Montecimone. Yes. From 2018, and I'm just gonna select now a couple of days here from January. You can select those time frames as well, and so on. And it will take a little while because there's a lot going on now in the background. But what you get then is a what Ida showed you, a footprint for this one station. And because I have only a few days, it is now very small and not very representative. But you will get results for population sensitivity, point source emissions, stuff like this. And it's still running, so there will be more plots available here. But it shows you what is possible to do in a Jupyter notebook with a graphical user interface here. And don't forget, this is, so if you go to this on-demand calculator, which Ute showed you in the very beginning of the presentation, so you can create your own station somewhere and run this Stilt model. Once these results are available, they will show up in this list here. Now it is still running. So you can create your own station, run the Stilt model, come back in here, select your own station, and create this additional data product, so to speak. I'm always talking too much.
Sorry, but this is possible with an ordinary account at the Carbon portal?
Yes, it is
Yes.
all public available,
Okay.
public, free.
And if you don't have an account at the Carbon portal yet, it is not so complicated to get one.
Okay.
Just go to the Carbon portal website
Okay.
and then.
Okay. Currently, we have got the password MSA. Well, I already had a different one. Okay.
Yes, this one is really only for this Explore Data service.
Okay.
But there is a general password for the Carbon portal where you can, with which you can then use the on-demand calculation, for example. These are two different passwords, two different accounts, so they are not synchronized.
So this Jupyter instance you logged in with MSA as a password, this is public available to the world, and that will stay like this. So in a week's time, in a month's time, whenever you like, you can just go in and play around with those Jupyter notebooks. And I really do hope that you, yeah, if you want to do like a fully fledged graphical user interface, like with the station characterization, it takes a little while to program that, obviously. But I really do hope that you see how much it is possible to give the user an interaction and the possibility to use the data and kind of keep the transparency and the reference points to share your work.
Claudio, I think we saw this and I see the potential and I always liked it. But do you see any drawbacks also? Is there something that we should consider and know?
Well, one thing is what we are working at the moment is that we would like to be able to freeze a Jupyter notebook, so to speak, that you as a user can say, I am happy with this notebook, with the results and everything. So let's get the PID for this notebook, so it will never ever change again. And at the same time, what we are looking at is to provide the computational environment, the complete computer, so to speak, to run that notebook, because it is all based on Docker files. So the idea is that you have a complete computer with data and code stored, and you get the PID for that. And this is, as far as I'm aware, not available anywhere in the world. Because the drawback as such is that Python is so popular that you will get almost any day an update, which means that you do something and it is possible that it does not run anymore in 2 weeks' time. So yeah, this is something we have to be very, very careful. So even if you are able to share the code and it is all transparent, if you can't run the code in a year's time, then it is, well, not useless, it is still good information, but it doesn't really help.
Thank you.
I have a question regarding the data that is free, no? Like, to what extent, like, the whole process is free? For instance, does the quality check, if somebody wants to see how the quality check was performed, is it possible? Or to see how the ontology was made, is it possible? Or it's just like when the data is kind of ready to use, then it's available? Where do you draw the line, like at the moment that the data is freely available or not?
So as I showed in the data portal on the left side, this filter, there is a level 1 and level 2 you can select. Level 1 is, well, I call it raw data now. It is not a very good expression, but it is like we get the data or how it is observed. Level 2 is quality controlled, quality assured. So you have access to the raw data, so to speak. Lynn has now gone, I think. I can't see her anymore. Oh no, she's still here. So for the
I'm
atmospheric...
still here. I'm still here.
Yeah, sorry, I saw you. So Lynn has written a paper, for example, about how all the quality checks in the atmosphere stations are done, which is available, which is cited. So you can see the whole process from the raw data, how it is processed, and you can get the high quality assured data. So what we try to do is to have the process transparent, but we encourage people to use the level 2 data because it is a lot of work that Lynn and people are doing to make this data as good as possible. And please do correct me, Lynn.
Yeah,
this
that's
is
okay.
more your expertise.
Just to answer the question, what you draw the line on how to get the metadata about how the quality engine has been done on the data. The carbon portal is not taking everything. So it's taking, I mean, when it comes down to atmospheric data, so data coming from the atmospheric thematic center. Here we have all the processing. So as Claudio said, we have a paper. If you want really the holy grail details about it, you have to go there. We're not pushing everything. We're pushing information. There is a quality identifier for each piece of data. And if you want to know what is behind it, then you have to go to the provider. In this case, it's us. For all the types of data, you have to go elsewhere.
Super. Lynn, could you place the link for the paper on the chat?
It's in the last example, the time series notebook we did, there is a link there.
For the quality checks?
For what? Yes, the paper. Let's see. The one with the time series, I think I saw the link. Let's see, exercise 4. I think I saw my name somewhere, so I think there is a link.
So you have it at somewhere you have the whole.
Yes, it's I think it's there. Anyway, if you download any data from the carbon portal for atmospheric data, you will find the link there. It's in a header.
Now, my question is more like, where can I see the process of the quality check documented?
Yeah, in this paper.
In this paper. Okay, super. Yeah, thank you.
You're welcome.
And then on top of that, ICOS has produced a huge amount of documents, starting from how to set up the instrument, how to calibrate the instrument, how to collect the data, and then it is provided to the thematic center and all the quality check. So this whole process is documented and available through those different websites at the thematic centers. So it needs a little bit of work, but the whole data flow and what it is done is available.
Claudio, but these are PDF documents. It's not machine readable. I just ask, or do you have already machine readable protocols for that? Mm-hmm.
No, this is text, and certainly yes, that would be nice to have as well, but we are not there yet.
Yeah, but yeah, I'm looking for them for smart protocols, but yeah.
Well, so we have used up a lot of time. If there are no urgent questions you have now, I think we can wrap it up. And as Carolina said, at least one of us will be available on Friday when you have this time slot to work on the exercises. The slides are available on the website through Lucia. Thank you. And if you're stuck or whatsoever, then write us an email and we try to help. Thank you very much.
Thank you very much.
Thank you.
Is there anything from your
Thank you very
part
much.
that you want to, as a final word, or is it
Very much.
okay to leave?
Your final words were perfect.
Yes, exactly.
Good.
We
Okay.
will share the recording, and I'm going to send an email to each participant to recap some useful information with some links and other info. So they will receive everything. Thank you again.
Thank you, everybody. Bye.
Thank
Bye.
you.
Good day.
Have a
See
nice
you
day.
next time. Bye.
Bye.